It's loading. You're good to go.
Okay, good. So I think we can start. Good afternoon, everyone, and welcome on this webinar on in part of the European AI Week on sustainable AI, on a key asset for European sovereign AI. In the next hour, we're going to give you a bit of an overview of some topics that we've been working on, both at the side of IMEC and also more recently the side of Openchip. Maybe just the first practical part before we get started. This is a webinar, but so you're watching a YouTube link normally. If you have any questions, feel free to already put your questions into the live chat. There's a lot of time at the end of this presentation to answer your questions as well. But so feel free to already type them in while we're talking, and then we can take it from there. So before we get started, let me first introduce who we are. So my name is Steven Latré. I'm currently Vice President AI and Algorithms at IMEC. I'm responsible for the AI research at IMEC, but very soon, and actually in 10 days from now, I'll be transitioning into a new role at a new European startup called Openchip. More about that in a second as well, where I'm going to be Chief AI and Software Systems Officer for Openchip. I will also remain an advisor at IMEC for the AI strategy. And also with me, we have Tamara de Swerts. She's a Strategic Development Manager AI at IMEC. And together we're going to talk about the need for making AI more sustainable on the one hand, and also how Europe can play a very important role into that. I think it's safe to say that at this moment in time, we're in a very strong AI race right now, with a huge amount of progress going forward on a wide variety of technical topics. Only the difference between 2001 and 2025 right now, we've seen new models like ChatGPT popping up, new advancements in robotics and so on. And we've really seen it from a geopolitical level. There's multiple countries really stepping up their game as well. That's at least what you see if you look at the last 4 to 5 years, an unbelievable explosive growth in the adoption of AI. If you go zoom out a little bit more, I think it's a much more bumpy road going forward. AI is clearly in a huge hype right now, but it has had its winters as well in the last few years, and often these winters were linked to a lack of computational power as well. What we're going to talk about today is what is fueling all of this, and how can we, as Europe, can also make a dent in this. And so, if we talk about what has been fueling all of this going forward, I think it's safe to say that chips have been a bit of the engine of AI and AI progress. The reasons why we've had AI winters over and over again was often because, from an algorithmic point of view, we had huge progress already that we made, but at the same time, from a computational perspective, we didn't just have the computers that were fast enough to work with all of this, and that was a result why we had all of these winters. So what we're going to talk about today is to see, to some extent, are we again going into this kind of winter as well, and what can we do about it, especially from the perspective of Europe. Just to give you an idea of how this chip industry has evolved over the last few years, if I look at the very first computer I had at my disposal was actually this device. I would assume that some of you have still also played with it. In that device, there were only 3,500 transistors, and that's about 30 years ago. While today, if you look at the most powerful AI chips today, we're talking about 280 billion of transistors. So really an unbelievable, explosive and exponential growth of computational capabilities in allowing to build really large-scale applications, and more particular in AI. And this growth, because of Moore's law, because of evolution of better and better chips, once in a while we get these new type of generations of applications that pop up. If you look at it really from a very historical perspective, we started in the mainframe area. We went to personal desktop computing in the 80s, 90s. From 2000, end of 2000s onwards, we went to mobile computing, so pocket computing, things like smartphone. And now I think all the different chips that come out are really at the level of really building centralized AI systems, so building large-scale models going forward. So what's next on this? I think we're already very strong in this centralized AI, but as chip technology is progressing, we're building smaller and smaller devices, so smaller and smaller components within all these chips. And I think there's for sure a next wave happening right now as well, where the type of technology that we have in chips can also be applied to a wide variety of new applications as well. Just as an anecdote, if you look at the most complex machine right now in terms of chips, we're typically looking at technology which is at the level of 5 nanometer, and actually even smaller as well already. So just to give you an idea, 5 nanometer means 5 nanometer thickness of the wire of your transistor. 5 nanometer is about, give or take, 20,000 times smaller than a human hair. So that's the size of how we're making chips nowadays. If you link that to actually what we have in our cells, in our human body, the thickness of an RNA polymerase is actually only 10 nanometers. So we're actually already building chip technology which is much smaller than what we have in our human body. So we're really at the atomic level right now of how chips are being made. As a result of that, the next wave that I think we can expect is still going to be AI, but it's not only going to be centralized AI like large language models going forward, but it's much more going to be AI with the intersection of things like life sciences or physical AI as well. Last week, or this week actually, Jensen Huang gave a keynote where he was also advocating, or at least the term physical AI, where we're going to see AI in every single environment as well, whether it's robotics, automotive, or just a simple sensor on a single device as well, maybe interacting with our body. And I think we're seeing already these first signs of this as well. This year, the Nobel Prize for Chemistry went to an AI model that allows to predict protein structures, and could in that case be really the key pivotal moment of really building very personalized drugs based on personalized information from you as well. Also, a few months ago, the finalists for the Gordon Bell Prize were announced. Well, 7 out of 9 of these finalists were all looking at how you can use AI for new things like drug design and finding molecules as well. So that's definitely the next frontier going forward, where a model like ChatGPT, a large language model, is allowing us to help us with efficiency. The next wave is probably going to be AI that is very much ingrained with very personal and privacy information as well, information from ourselves, in that sense. So I think it's clear from an application perspective, this is far from over. There's still a lot of things and a lot of applications that are ready to be revolutionized as well, and especially AI and life science is going to be a very big one as well. I think going forward, I think one of the biggest frontiers that we're slowly building towards, and where IMEC, for example, is also building sensor technology for, is that it should be possible going forward that you could take a very small swab of yourself, just like you would do if you want to do a DNA analysis. You could do the same thing later on, bring that towards AI, and you would have a full view of every disease you would have right now, and we could actually build personalized medicines later on as well. This is a futuristic vision, but it's one that is actually just around the corner as well. So from an application point of view, these are unbelievable applications. But at the same time, it also warrants the question on, okay, this is great that we can more and more do this from a application point of view, but from a societal perspective, I think we should also ask ourselves, yeah, do we want to build this? And specifically, what kind of AI do we want to build in all of this? Because of course, AI, it's a system technology. It will probably be as disruptive as the internet has been in the 90s. The way we build this kind of AI is going to be very important for our generation and all the next generations to come. It's extremely powerful, can do a lot of good things, can also do sometimes detrimental things as well, and we need to balance these out. And if you look at it from a geopolitical perspective, I think it's we're a bit in between a rock and a hard place. And so it's clear that at this moment in time, in this AI race, Europe is probably lagging behind a little bit. So on the one hand, we have great progress in the United States, both at the application side and at the chip side, on new applications such as ChatGPT, Grok, and so on. But also more recently, we've got a lot of announcements at the Chinese level as well, with the Manus AI just 2 weeks ago, and of course, obviously DeepSeek as well. In Europe, we're both physically, but also definitely virtually just in between of these very large AI regions as well. And it's hard for us, I think we need to acknowledge this, that it's hard for us to really know exactly what's the best place for us to do all of this. On the one hand, I think it's clear that there are a lot of concerns on the way China, for example, is adopting AI. This is just one example, but privacy concerns are less of an issue there. This is an example of how China is using simple computer vision models to detect whether you're jaywalking in the streets or not. Using very simple computer vision, you're immediately being recognized based on facial recognition, and your name and social security number is being advertised immediately on a large public display. These are applications of AI that are also in the AI Act are clearly prohibited, and Europe is taking a clear position on this, that this is not a type of AI that we want to have going forward. But also at the US level, I think there are sometimes some concerns as well on how AI is progressing there. Just if you look at how the news has evolved in the last few weeks, in January, under the Biden administration, it was interesting to see how Biden has, or the Biden administration has actually restricted the export of new AI chips to a number of member states in the European Commission and European Union. In that states actually also splitting the idea of one unified market. So countries such as France, Belgium, Spain, they're in this tier one of getting access to new AI chips. So think of the NVIDIA chips and similar. They get still unrestricted access to these new AI chips, but other countries, such as Luxembourg, for example, is only in the tier two and is from now on restricted on how much AI chips they can buy going forwards. So this shows that as Europe, we're more and more dependent on other technology as well. From an safety perspective, in that sense, we also see some worrying aspects from time to time as well. Under the Biden administration, there was a first law, kind of a lightweight version of the AI Act that forced large language model providers to warrant or to at least warn if certain safety issues happened with large language models. They needed to signal this to the US administration. Very recently, this executive order to have a kind of safe stop on specific AI risks has again been revoked. And so we see at the EU side a kind of trend on deregulating aspects as well, while in Europe we have the tendency to regulate a lot of things as well. And third, new initiatives like Doge look at how AI can be used to replace human labor, specifically in the public administration. But that, in a sense, also provides some security risks because a lot of data is being centralized across different departments as well. So you see that there's two different flavors of AI in China, where on the one hand, where data and data privacy is less of a concern, and here there's in the US, it's also a matter of less regulation going forward. And as Europe, we're very much in the middle of all of this. The AI Act is on the one hand a very important mechanism to protect the safety and the trust of AI, but we also see that it's not providing the right type of ground for really flourishing AI innovation as well. And every time to time, there's a European AI player that is popping up, but is also having trouble in really further developing its own company. And just a few examples of this. For example, Aleph Alpha, which is still a German large AI provider. They started, or they tried to build a large language model as well, which was 100% European, but they pivoted a few months ago just because they were not able to actually carry through in Europe because of that. Similarly, Mistral has succeeded in building such a European large language model, but is also very much dependent on US technology to allow all of that. And more half a year ago, Silo AI, which was also a large AI provider, has been bought also by AMD. And so you see that it's a difficult situation for Europe. On the one hand, we're trying a lot to catch up in this race as well, but it's not the right, or maybe not the best environment going forward. And so the question remains, what kind of AI do we want to build, and specifically what kind of AI do we want to build within Europe as well going forward? Europe has a very good, strong set of European values, and the AI Act is actually a very nice example of how it's also showing what these values should be. But at the same time, I think we do not have the technological solution to address all of this. While on the other hand, especially from a research perspective, labs like IMEC, Latré, Fraunhofer, but also more initiatives such as Claire and Alice, they are actually bringing a lot of centralized, concentrated AI knowledge at the European level as well. And I think we're sometimes underestimating how strong we are as a European region. I think we're specifically strong on three aspects, which are, for me also, from a European perspective, probably the biggest challenges going forward for the future of AI. And those are, on the one hand, sustainability, on the second hand, scalability, and on the third hand, trust and safety. And what I want to do in the rest of this presentation, I want to give a bit of an overview of how I think we see challenges and issues in current AI, but also how we as Europe can probably play a very important role in further developing all of this. So starting with sustainability, what is the challenge there? The progress that we made at the application level on AI has been really, really tremendous. But also what we see is that the amount of power consumption that we need to build and to drive these applications is also enormous, and probably even too much going forward. What you can see on this graph here is how neural networks, so the basic component of AI, has evolved in terms of training complexity. So the amount of computations you need to build such a neural network. And you can have a similar graph for the inference as well. Until about 2010, what you had is that the training complexity doubled more or less every 2 years. And doubling every 2 years is not really a big problem, because we have, thanks to Moore's law, if we double from an algorithmic point of view the complexity every 2 years, we can do this more or less with the same hardware, or at least at the same type of cost as well. Hardware will have evolved as well, and that's not really a problem. However, since 2010, what we do see is an increase, thanks to a lot of advancements in the software space. We see an increase in the training complexity and the training requirements. We're now up to a level that we need that neural networks are growing at a factor 100 every 2 years. So from a software perspective, we're further and further and further diverging. More and more requirements are being put on chips and computational infrastructure to follow suit. But if Moore's law is doing anything, it's at least not increasing, it's actually slowing down a little bit. So it's becoming a bigger and bigger growing divide. And you see this very clearly, how big investments like Stargate, which was announced very recently, is requiring billions of investments to build the future of AI as well. And this is really a problem also specifically from a chip infrastructure and a chip capability as well. We see that the last 10 years, we've made a jump from CPUs to GPUs, where GPUs are much more powerful in training AI systems. But the performance and the evolution of these GPU systems, despite what you might think, they haven't evolved or they haven't improved at the same rate as Moore's law even. If you just look at the last few years, the GPUs aren't really getting much better. We're plateauing again after we got this initial jump from CPU to GPU. So GPUs have only become better for 15% in the last 2.5 years. If you look at it in the number of operations they can do per square millimeter in that sense. And so the next step is definitely going to be that we need to solve, both from a software and a hardware perspective, really that combination together to make sure that models can run much faster in a much more energy efficient way to do all of this. And this is for sure a problem, and a problem that the whole AI community worldwide is being faced with. OpenAI is explicitly looking for trillions of dollars of investments really to solve this issue. So very recently there was an announcement, or about a year ago, that Sam Altman from OpenAI is seeking trillions of dollars to really build new types of fabs for fueling AI. A few months ago, he was also allegedly been dismissed by TSMC because he had absurd requests of building more than 36 more fabs to build these chips. And very recently, we've seen a lot of companies like Google, but also OpenAI, actually turn to nuclear power as well to fuel the next generation of AI data centers. And so this is clearly an issue we have. And going forward, I think this is one of the major challenges that we need to address for AI to really flourish going forward. If AI is not able to really solve this sustainability aspect, it's probably not going to be something in a technology which will be able to evolve as rapidly as it has evolved over the last few years as well. Now, is there something we can do? I think there's absolutely something we can do, especially if you look at the amount of efficiency gains that we can still have. If you just look at it a bit more philosophical, our human brain consumes about 20 watts of power. That resembles about 1 exaflop of operations. If you link that with how efficient current hardware is, we are able to build an exaflop computer right now, but it requires about 20 megawatts of power. So we're 1 million times less efficient at this moment in time than what the human brain is. So that's still the efficiency gap between us as humans and the brains of the current computer chips. The only way to solve this is by having a very strong hardware-software co-design where we change both the software and we change the hardware, and together we make important efficiency gains. And there's clear examples of this already. Only a few months ago, DeepSeek was a pivotal moment in that sense, because DeepSeek is using new types of algorithmic approaches to deploy it on cheaper hardware, but it's also changing actually the way the software is mapped to the hardware as well. And it showed very clearly that with that, you suddenly were able to get a huge improvement gain. And so in that sense, DeepSeek has been a bit of a, I think, wake-up call both for traditional large language providers such as OpenAI, but it can also be a wake-up call for Europe, because suddenly the playing field of how easy it is to get into this AI race is suddenly wide open again. And I think it should be a bit of a wake-up call for us as Europe to develop these own models as well and be very strong on this hardware-software co-design as well. And the good thing is that as Europe, we actually have much more gems than we think we have. There's a lot of key assets in Europe on this level of hardware and software co-design that allow us to build a more sustainable artificial intelligence going forward. I think, of course, we have the advantage of IMEC, who is a worldwide leader into this, but there's also a lot of other labs in Europe as well who have really this focus of sustainable AI. For example, in France, sustainable AI is one of the key topics for the French AI plan as well. So just to give a bit of information of what we're doing at the side of IMEC here, we are building new technology that allows you to build really huge improvements in the order of factor to 100 to 1,000 of being more energy efficient in terms of AI. It's just a matter of further maturing these types of technology, and these could really result in a large breakthrough as well. Without going into too much details, two things that are worth mentioning. One technology that IMEC has been developed over the last few years is what we call a superconducting digital computer. It's in essence using specific superconducting materials, a computer which has the potential of being 100 to 1,000 times faster, and actually provides you the capability of building a data center with the size of a shoebox. You do need to refrigerate that shoebox because it's only able to work under environments such as minus 35 degrees, but it has a huge potential of really exponentially improving compute. And more applied, we're also looking at programmable AI chips where on the fly we can actually reprogram the entire AI for specific tasks. So on the one hand for sensor fusion, on the other hand for large language models as well. So these are assets where, thanks to this combination of hardware and software, we really as Europe have a role to play as well. So that's one part, the sustainability part. And you might think that new advancements such as DeepSeek have actually resulted in a much less of an issue of that. That's a comment you often heard in the very first days of DeepSeek. Well, DeepSeek is now showing that this issue has been solved. And I think it's quite the contrary. What you see is that DeepSeek has resulted in an improvement on how easy it is to build a large language model. But the future is for sure going to be that more and more of these models are going to be used, and the amount of computations that we're going to need is actually going to grow exponentially as well, because we're going to make these models bigger and bigger, and we're going to make these applications as well bigger and bigger. And this is a trend you see already very recently with Agentic AI. So for those of you who are not familiar with Agentic AI, it's basically the next generation of large language models where you're not using a single large language model anymore, but where you're using a combination of multiple models, where one model talks to another model to improve of its reasoning capability. And suddenly you get into a kind of reasoning loop where you don't have a one-shot environment where you would ask a ChatGPT with just one single prompt, you would get one single answer. No, you get kind of a network of different agents or models that are talking to each other, linking data with each other, exchanging data with each other, and suddenly improve very strongly upon the results. A very nice example into that is the recent Chinese startup called Manus AI, which is essentially an agentic workflow to do a large generation of different tasks. Here you see Manus AI at work, and how it's able to build you an entire itinerary for a 10-day trip to Japan, including where you need to book the flights, which restaurants you need to book, how you need to get your visa requirements, and so on. So you see that from a computational perspective, this is not a one-shot thing anymore. Suddenly you have models which are thinking for a very long set of time steps to really come up with a very impressive result as well. And I think we're going to see a lot of applications in the agentic sphere going forward. And that actually provides, when we scale these things up, this provides an even bigger challenge when it comes down to compute as well. I think there's 2-3 years ago, we had what we call the one single scaling law. And the figure I just showed you a few slides back, where models were just becoming bigger and bigger. Now we're seeing 3 different scalings law. We're still seeing the scaling law of, okay, we need to make these individual models bigger and bigger as well, but we're facing a bit of the law of diminishing returns. We cannot make these models, so these ChatGPT, large language models, bigger and bigger going forward. But now 2 new applications of neural networks are arriving, where we're on the one hand using fine-tuning of models to make these models more efficient and more intelligent in terms of capabilities as well. This is called the post-training scaling law, where you're adding additional data to your model to make it more quote-unquote intelligent. This has been going on already as to compute scaling law, where agentic workflows are allowing a model not to work only with one shot, but where you really have hundreds and hundreds of reasoning steps that go further and further. So if anything, the problem has actually been increased further on as well. We've really seen now that from this initial model, so the slide I showed you a few slides ago, to this test time compute scaling law, the assumption is that we're probably going to need about 100 to 1,000 times more computes just to go from a single model to an agentic workflow as well. So if anything is happening, because of the scale, we need more and more compute going forward. So the first 2 really focused on the compute aspect. So how can you build it more sustainable? How can you also scale this up? The third one is really on safety as well. AI is a great technology, but the more and more we're going into the realms of agentic AI, we also see that the applications and the capabilities of what AI can do is tremendous, but the amount of safety that is in there is also, or the safety risks that are in there is also very much an issue. You can define safety in a lot of different ways. There's a lot of examples on this. One thing we do see is that for large language models, from a privacy perspective, they're not always best in class. We've probably all heard about the copyright infringement that ChatGPT did on text from the New York Times. And very recently, only a few days ago, Sam Altman also spoke up on this, and he said that privacy is actually an issue that should not apply to large language models, and that he wanted to be able to use freely all data that is out there to just develop the future of large language models. This shows that privacy, but also further on trust, these type of aspects are absolutely a challenge going forward as well. So especially if we go into the realms of agentic AI, different types of applications there, it is going to be important to think of how can you do this with the right type of privacy, with the right type of security around these type of models as well. And this is just a field that is very largely emerging with the capabilities of what AI can do. I think on these 3 different levels, from sustainability, scalability to trust and safety, this is, I think, the unique combination where Europe can really play a role in. We are at this moment in time definitely not an European AI champion, or we are not a champion in the AI race. But events like DeepSeek is showing us that we're actually in a marathon and we're not in a sprint. And it's really possible for Europe to still get ahead in this race as well, as long as we focus on the right type of topics. And scalability, sustainability, and trust is absolutely going to be the key pillars going forward. Key pillars for Europe, but actually also key pillars for AI to further flourish. And the way where we can get this most guarantees going forward is also at the computational chip hardware level. We have a lot of assets within Europe where we're very strong on this, and the type of requirements that we need, both computationally and safety, we're only going to be able to reach this if we do this also at the hardware level and not only at the software level. This is actually what DeepSeek has shown very clearly as well in that sense. And just to reiterate, so these are the pillars that we need, and I think in Europe we do have a lot of assets on this as well. But at the same time, this is a wave that is coming, and I think it's important that we not only do this within research, but we also start building within Europe clear products on this as well. And that's why there was an announcement last week very strongly that IMEC is also partnering with Openchip, which is a European startup right now, especially on this topic, to really make sure that we're able to build advanced AI technology going forward as well. So before I hand over to Tamara, let me first very briefly talk what Openchip is all about. Openchip really has the intention to build exactly what I just talked about, to be the European AI system company of reference, to focus on these three different pillars. So really technology at scale with a link to sustainability, and to build also safe and trusted technology for citizens as well. And we believe at Openchip that the only way to do this is by really building both the hardware and the software at the same time, with these mechanisms by definition, by design at hand, already baked in as well. So Openchip is building a chip that has specific levers for controlling sustainability, for controlling the models of your, for the safety of your models, and is able to scale up as well. And we're going to build in the next years the right type of software platform to run on top of that as well. Going forward, I'm going to make a transition from IMEC to Openchip to be responsible for the software and AI platform going forward. And just a few more words about what Openchip is. It's a very young company, only 11 months old. In August, it was only with 37 people in 2 different countries. Now we're with 130 people right now already, and we're opening up offices in various parts of Europe. We just opened this office in Belgium as well, really with the goal of being a European, pan-European player as well, and to hopefully in a few years from now to say that as Europe we're also ahead of this AI race on these particular topics as well. And maybe a very last shameless advertising slide on my side. We are hiring very strongly across the board. There's more than 100 vacancies at this moment in time at Openchip, from junior to senior to director level as well. So if you're intrigued about the vision of building this European AI player, feel free to reach out to me personally, or to just go to the Openchip website and apply. Not all vacancies are online, so feel free to reach out to me, and I'm happy to also join the conversation there. Okay, before we open it up to questions, I would like to also give the floor to Tamara, because of course, building AI also means that you need to test and validate all these AI concepts as well, also from a computational perspective, and this is what Tamara will talk about.
Yes, thank you, Stefan. A little bit more from a practical perspective, if you go to the next slide, is our Edge AI testbed that we indeed are building at IMEC. It's part of a bigger European project, the test and experimentation facilities that are being established under the supervision of the AI office. So there are 4 sectorial TEFs: health, manufacturing, agri-food, and citizen communities. And IMEC is active in the last one, citizen communities, and so in that theme, let's say, that we are putting up the first proof of concept of our test beds. What's the goal of the testbed? Of what do we want to create? We basically want to create a collaborative platform to foster innovation amongst the chip designers, the sensor and data providers, and the algorithm creators. Exactly what Steve said. In the future, there needs to be a much more stronger collaboration between software and hardware. And today we see that those are actually 2 separate worlds. Especially also from a timing perspective, chips are created on a much longer timeline, 2-3 years before some piece of functionality is shipped. On the software side, software is being shipped in some companies in minutes. So that means that we are quite some hurdles to take also to bring those various people together. And basically we need to create a paradigm shift in how software and hardware is worked, how those 2 are working together today. So we want to build a platform to basically foster that and to accelerate the deployment of edge AI technologies by providing robust infrastructure so that the prototyping and validation on the 2 sides can happen more rapidly. And we also, and indeed with seamless integration, because it's not that simple to let those different components talk to each other because they are currently so separate from each other. Now, if we go to the next slide, what is the difference between AI in the cloud and on the edge? If you see today, almost all computation is happening in the cloud, which basically means that every piece of data is being moved from the edge to the cloud to compute over there, and then results are going back. So what's the idea of edge? That more and more compute is happening on the device itself. As you can see on the next slide, the data is then not moving upwards anymore to the cloud, but stays on the device. And then on the next slide, that also means that the computation happens on the edge and that you also need to have the hardware available to do that. And that you can also create algorithms that can operate much more on real time and have much less latency. At this moment, this is already happening, but for very simple algorithms. And our idea is that we can do that in much more sophisticated algorithms so that we need to send less and less data to the cloud, and we can do much more on the edge. Now, if you go to the next one, edge in a nutshell, because less data needs to go to the cloud, that also means that it can be much more privacy safe. Because at this moment, that's one of the biggest hurdles, especially in a more public environment, that a lot of innovation is getting a lot of pushback because of privacy reasons. And that instead of becoming looser or like other regions in the world with privacy, we want to basically embed the privacy in the solutions that we are building by letting them operate more and more on the edge. If we do that more and more on the edge, then we also need to do that in a much more energy efficient way. The power consumption is often limited on the edge, and that also contributes to the fact that we want to build much more sustainable AI and reduce the computation that is needed for the models. And then a last big advantage of edge is that you can make them much more connected. So each of those sensors and IoT devices that you see the growing amount of IoT devices and data that they are generating, that we can also connect that much faster to each other and basically create much more of an ecosystem of individual workflows. And then next, an example of an edge device is actually an autonomous vehicle. Today, you see that those vehicles are surrounded by sensors, and that actually also needs a lot of computational power, especially if we want to let them work autonomously and let them make decisions on the spot. And I think for the automotive industry, that's a very big challenge, which can be resolved by better computation on the edge device to really make a difference also in Europe when it comes to autonomous driving, so that we don't eat the battery, but that we can extend the driving time of the cars by doing our AI in a much more sustainable and efficient way. So very practically on the next slide, what is the offering of our testbed? So we are actually building a set of next generation off-the-shelf sensors together with chips, AI chips, and a growing set of AI chips that we have in our availability, which we can combine in a flexible way in a static and a dynamic setup to do tests in the real-world environment to basically validate AI algorithms on the one hand, but also the hardware and the combination of the two together. So there's a physical infrastructure, but we also then, of course, are building a virtual infrastructure on the next slide, where we combine one platform in a seamless way to combine the chips with the sensors and with the AI models, and that we can basically benchmark the results and see for each type of combination what is the best combination and where are we losing energy, losing time, losing accuracy in the models to basically optimize the software and the hardware altogether. And then our first proof of concept on the next slide is going to be in the city of Mechelen, where we will install a setup on a car and in an intersection in a mobility setting to basically test the various models and chips available all together so that the trained models can run on the edge on various hardware. And I think that was, the benefits that we envision is, of course, we want to foster innovation. We want to share the resources, because if each company needs to basically buy all those sensors and chips, etc., individually, especially for smaller startups, that can be a hurdle. So we want to basically leverage the power of the community and the ecosystem to bring that all together, so that we can all work together and exchange not only tools and equipment, but also the knowledge that we have built up by benchmarking all the individual combinations and really create an impact by solving real-world challenges with the most sustainable AI technology available. Thank you.
Good. Thanks a lot, Tamara. So I think this shows very clearly how the broad spectrum of what we can do at a European level, from really building next generation of chips, but also really with this hardware software co-design principle, which is essential for the future of AI, to already test it right now as well. So I think if you have any questions, feel free to send them also in the chat. We'll wait a little bit to see if there are any questions popping up on the YouTube channel. I have an eye on that as well right now. So we're going to wait a few more seconds to check if people are having questions, and if so, we're going to address them. If not, we're going to leave it by this. If you want to know more about this, so either if you want to talk about the test beds, which is, I think, a perfect way to assess your own models in an edge environment, you can reach out to Tamara. If you want to know more about the plans at Openchip, you can reach out to me as well going forward. Just trying to fill the empty space a little bit to see if there are any questions, but I don't see any popping up at this moment in time. If not, I want to thank you all for the attention. We had quite a bit of attendance in the YouTube channel, so nice to see that there's a lot of interest in this. Thanks a lot for dropping by, and I wish you very other interesting sessions in this EU AI week. Thanks a lot. Bye.
Thank you.